Hello guys, it's Math with John. I have problem 3. Yeah, so let's do this. Okay. So, it says a ladder that is 12 feet long is leaning against the vertical wall with its other end on the ground. The top end of the ladder is sliding down the wall. When the top end is 7 feet from the ground, it is sliding down the wall at 2 feet per second. How fast is the bottom moving away from the wall at this instant? So, we know the ladder is 12 feet long. But then we know that it's so it's like we have a ladder, but then it's leaning against the wall. But then the top end of the ladder is sliding down the wall. So the top is kind of like just sliding, you know what I mean? It's just kind of going down. When the top end is 7 feet from the ground, so the top part right here, if we look at it, is 7 feet from the ground. And it's sliding down the wall at 2 feet, so this part right here, it's just sliding down. You see this part right here? And it's sliding. It tells us 2 feet per second. But then it says how fast is the bottom moving away from the wall at this instant. So I didn't draw the complete bottom, but the ladder, you see this is my ladder. Like, let me make it kind of look better. See, we have a ladder. So we're trying to figure out how the bottom is moving away from the wall. Okay, so I'm thinking like, how can we look at this mathematically? So far I just kind of showed you guys how I would kind of approach this, I guess, equation if it was just not mathematically, just visually what it looks like and based on what we're told. Well, we could take this and you know, what did we learn in algebra? We have the, or in trig I should say, because this is more of a trig. Well, we could look at this as the Pythagorean theorem. I love Pythagorean theorem. This guy, he did get the credit for discovering the Pythagorean theorem, but you know, he didn't actually discover it. If you guys like math history, he was actually really into music, and a lot of people don't know that. He wasn't just, and that's the reason why he was so interested in finding like different things. So yeah, so we have x squared plus y squared equals L squared. The reason why I wrote L squared is I guess we should write it like this: a squared plus b squared equals c squared. That's the actual Pythagorean theorem right here. But the reason why I wrote x squared plus y squared is because what we're actually dealing with is like, I'm viewing this as, you know, we have our x and then we have our y right there, and the L is for the ladder squared. Okay, well, actually, yeah. And after that, let's just differentiate both sides. So if we start dealing with the, see, we have 2, so right here, so it's gonna be 2x, and then we take the derivative of that, so it's dx over dt plus 2y, and then we have dy over dt equals, and then 0. And yeah, that makes sense. But then it says, like, at a given moment, right, that the 7 feet, it's from the ground. You see how right here, this is 7 feet from the ground. This is our ground. The floor is right here. You see it's flat. Well, we can find, using the x squared plus y squared, the Pythagorean theorem is useful right here. So what we could do is right here is plug it into the Pythagorean theorem. Let's do that. So y equals, what are we going to have? We plug it in. L squared minus x squared. But then this equals root 12 squared minus 7 squared. And wait, what is that going to be? 12 squared. Let's see. Let me check on a calculator. And then that's going to be root 144 minus some squared. So minus 49. And then if we simplify that, we get, use a calculator. Don't want to do basic addition. And then we get root 95. Okay. So, but now since we found the root 95, what we could do is plug it in. You know what I'm saying? This is what we were gonna use, but now we could plug it in for this. You know what I'm saying? Okay, so let's plug it in. Because we just found y here. So we just found y right here. And then and this was our x. So this will be right here we're plugging for x, and then right here we're plugging for y. I'm gonna try to keep it. And then let's plug it in. So 2 times 7. Yeah. 2 times 7. And then d over x dt plus 2 root. See, I'm like just literally plugging it in. Root. Oh man, I'm running out of space. I have a habit of writing too big. I think I sometimes forget that I'm writing on a phone. Honestly, I feel like I should have wrote on the side. Okay, let me just make it smaller. Wait, I think I could do it. So there you go. It's the cool thing about using a phone to do math. Okay, and then times -2. But make sure that you can see that I have a parenthesis here. And then multiply it. But then this is still gonna equal 0. So then 2 times 7 is gonna be 14. And then it's gonna be dx over dt plus, well actually what I could do is well, since we have the negatives, it's gonna be now negative actually. So we get 2 times 2 is -4. Then root 95 equals 0. Okay. Now what we could do is get rid of this 14. So let's just simplify that. So it's gonna be dx over dt. Move it to the other side. Now what it's gonna look like is 4 over root 95 over 14. You see what I did there? Because it was a negative, and yep, we were able to do that. It's the rule. I forgot the name of the rule. And now let me see if this can be simplified. Yeah, we could actually simplify it because we have this and this. It's gonna equal actually dx over dt equals 2 root 95 and then over 7, I believe. Yeah. And I don't think yeah, that's it in the 95. So that's what I got. I got 2 root 95 over 7. I think that's the answer. So, and then I'm just trying to check. Okay, I'm gonna share my screen right now in a moment. Yeah, so I just put it into Desmos. Let me show you guys. Well, Desmos. Let me show you. Okay, so in Desmos, I just kind of have a line. I put it in, and you see, it just kind of looks like a line. But what essentially would be happening is I'm not that good at using Desmos, but it would just be like moving. The more we kept moving it, the bottom. You see what I'm saying? Okay, so that's math with John. Until the next one, guys. So actually, yeah, and let me circle that. That's actually the answer that I got. Okay.